All right, starting this PowerPoint, it says, can I cut in? And so what we're looking at here is we're looking at the single replacement reaction. Now, learning goals for this. Students will rank the activities of metals using the activity series. We'll rank the activities of non-metals using the activity series, and we'll predict the product of a single replacement reaction. So what we should already know, chemical reactions change the reactants resulting in different products. Synthesis reaction, combined reaction, and decomposition reaction breaks a single reactant apart. And so, jumping into what we learned in the lab, certain metals can replace another metal in a compound, and the greater the activity of the metal, the greater the number of metals it will replace. And we see that copper is very easily replaced. Now, metal activities. Metals such as sodium and potassium are very highly unstable by themselves, so they will always want to form bonds. Now, these reacts will form when we form bonds. The metals will react to form more stable compounds. That's what it means by wants to react to form bonds. When sodium and potassium form bonds, they become more stable. Metals can react violently with water. So if we put pure sodium into water, it reacts violently, it'll blow up. Ranking the activities of metals. To do this, what we do is we use the activity series. And they're ranked by their stability. Least stable is on top, most stable is on the bottom. And so we have this list, and this is the activity series, which will be given to you. You don't have to memorize it, but it's just the activity series of metals. Now, anything that is unstable, those unstable metals will replace more stable metals. So if something is more stable, it'll replace it with the unstable thing. Now, metals higher on the activity series will replace metals that are lower on the activity series. So in a chemical reaction, if lithium is by itself and it comes into contact with anything, it'll replace it. But let's say that sodium is by itself and it runs into lithium in a compound, it's not going to bump lithium out of the compound. So if we look at this, gold, silver, copper, and platinum are very stable. They're down here at the very bottom. These metals are non-reactive, and these metals are used for monies, tools, and many other purposes because they are unreactive. Now, the non-metal reactivity, unstable non-metals will replace more stable non-metals. Now, non-metals higher on the activity series will replace non-metals that are lower on the activity series. And you can look at it, if you look at this, this is the periodic table. The activity series of nonmetals you can find on the periodic table, and it's just the halogens, because those are the guys that are normally going to be by themselves. And when those guys react, fluorine is the least stable, iodine is the most stable of those halogens. So let's look at our fundamental question. It says, what metal is the least reactive on the activity series? And so the one that we looked at, gold, is the most unreactive. And you'll see in really good electronics, they use gold in the microchips because it is unreactive. And especially, they'll use gold in things they send up in the space shuttles. Next question. It says, cans of food can be stored for a long-term storage. Which would be the best material to make a can to store food for a long time? So we would want something that's unreactive. And if you had the money, the best way to store canned food would be to store it in a gold can. Next example, it says, predict the products, if any, for the reaction shown below. So when we're looking at this, is barium above iron on the activity series? There's barium. And we see that we find iron, it's way down here. Since barium is by itself above iron, this reaction will take place. And what this means is that iron is now going to be by itself because it's more stable than barium. And barium is now going to be bonded to nitrate, and we create barium nitrate. And our mastery level question. It says sodium and silver have similar appearance. Silver has commonly been used for money while sodium has not. Why is this the case? Well, silver, since it's more stable by itself, can exist by itself. But sodium, on the other hand, is very reactive, so it's very hard to find sodium alone by itself. Generally, we have to decompose things to get sodium by itself. So, single replacement reactions. It is a class of chemical reaction. One part of a reactant combined or is replaced by a metal, and the molar mass can increase or decrease depending on the identity of that metal. Now, single replacement reactions, we're looking at one here. We have barium reacting with our copper 2 sulfate, and since barium is more reactive, it replaces that copper and creates barium sulfate, because barium is higher on the activity series than copper, so that barium replaces it. Now, energy in a single replacement reaction. Chemical bonds are broken in single replacement reactions, and chemical bonds are formed in a single replacement reactant. So the products of a single replacement have a lower energy state than the reactants. And so what we see is that more energy, the more unstable thing is becoming into the reactants. So it's at a lower energy state, and it generally releases energy. Some applications of a single replacement reaction. Single replacement reactions is commonly used in batteries to produce electron movement. And so we see that electricity is electrons, and it can basically flow in the battery, and that basically all a battery is a single replacement reaction. And we see that batteries stop when they run out of iron. Fundamental question. It says, give an example, story, situation of a single replacement reaction in real life. The reason why this is called Can I Cut In is essentially we see here, these guys will switch places, just like in our single replacement reaction, those guys, or the metals, will switch places. Next question, it says match the chemical reaction with the classification. Decomposition, we're going from one thing to multiple things. It's a guy right there. Single replacement, one thing by itself plus a compound, and it switches places right there. In synthesis, we're going from two things to one thing. Next question says, will sodium replace lithium in lithium chloride? Write a balanced chemical equation to determine the answer. So we have sodium, which is Na, plus lithium chloride, which is LiCl, and it produces, well, nothing, because sodium is not above lithium on the activity series. Sodium is actually below it, so there will be no reaction here. And our mastery level question. It says elements by themselves have a charge of 0. How do the charge of atoms change in a single replacement reaction? Give an example of how this can be useful. And so when we're looking at this, if we go back to our battery example, here's a great example of it. We have iron reacting with copper sulfate. See that iron is 0, and then it goes through and iron changes to a +2 oxidative state, and now copper is 0. And so you can take this, and because it changes those oxidative states, it becomes very useful, and we can use them in batteries.